time, we'd like to have some moderated panel discussions to go through a lot of these issues that have been raised in more detail with practitioners from around the world, actually. So for each of these, we're going to ask the moderator and the panelists to come up and sit at the front table. We ask that the moderator give a very brief motivation for the panel. Each of the panelists should discuss on the topic of that they've prepared for up to about 10 minutes. And then we want to save the last 20 or so minutes in each one for moderated discussion, which the moderator should, of course, feel free to ask questions to the audience, or take questions from the audience. So for this first panel, the topic is, what do we mean by reproducibility? The moderator is Florence Conlist, who joined the World Bank as a young professional with a PhD in economics from the University of London. She founded and leads the bank's impact evaluation program in agricultural adaptations. She also started Dime Analytics to help generate and curate more and better data for impact evaluation. She's running experiments in the fields of agriculture, justice, infrastructure, transport, and natural resource management. Joining her are Lorena Barba from George Washington University, who's an associate professor of mechanical and aerospace engineering at the School of Engineering and Applied Science at GWU. A leader in computational science and engineering, her research includes computational fluid dynamics, high-performance computing, computational biophysics, and animal flight. She teaches open research practices and has built a lot of platforms to deliver that kind of content widely. Owen Ozier is an economist with the World Bank's Development Research Group on the Human Development Team. He received his degrees in electrical engineering and computer science. I thought we were doing development here, guys. And from MIT in '99, and his PhD in economics from UC Berkeley in 2010. His current research focuses on health, education, and economic decisions in sub-Saharan Africa. We also have Cheryl Thompson from the Odum Institute for Research in Social Science, who's a research data archivist at the Odum Institute at UNC Chapel Hill. Her research focuses on knowledge infrastructure, specifically building and sustaining services, workforces, and tools capable of supporting scientific integrity. As an archivist, she's involved in the curation and reproducibility operations, as well as advocating for data sharing, transparency, and responsive data education. So I'll turn this over to Florence to give a brief introduction, and then each of the panelists can go. Some of you have slides. If you do, they'll be here. And if you do have any questions or need any help, I'll be right there.
Thanks a lot, Ben. So this is a real treat. Again, I repeat, being here today, having a whole day to kind of think about these issues of reproducibility in this really talented group of practitioners. I just want to, so I'm not going to spend a lot of time motivating this panel, because I think this morning and Ted's talk just really motivated the issue of why do we want to be able to call reproducibility? Why do we want to be able to establish standards? Why do we want to be able to think about this together, like following sort of similar guidelines and standards? I think for me, just since, Ben mentioned that we all have kind of weird backgrounds on this panel that are not necessarily straight up, economists. I also did my undergrad in applied math, and during my undergrad, I did a lot of, programming of things like AIs. And one standard for passing an exam or a project was that you could just do a turnkey, right? So you would bring your whatever little disk and your CD or whatever with your program files, and if your instructor couldn't run, your project from the get-go from that file, you were failed. You had a 0. And so this, to me, when I came to economics, and I sort of learned that people were doing things from the console and some crazy stuff like that, just really mesmerized me. I was like, what are they doing? This seems like a fail, So anyway, so I think this is sort of, this took us, I guess, as a lab, as Dime, to develop standards. I'm not going to take credit for this. Actually, Christopher, who's here, was my RA at the time. And Maria was the analyst on the team, when the three of us kind of put our heads together over a really nice lunch nearby. And we're like, the RAs, they all have the same question. This is so time consuming. So Christopher was already sort of a senior RA at the time. And he was like, I have so many emails from all these RAs asking exactly the same questions over and over. And so we said, so we need to develop off-the-shelf solutions for these guys so that we don't spend all our time doing this. And then said, where do we put the shelf? What are the shelves? That's when the wiki was born. And all this suite of commands started to be coded and put together. So this is really nice to see that everyone in this room has sort of gone through the same experience, and that we've all produced a lot of global public goods, I think, in this space. But to turn back to the topic of the panel, which is, what is reproducibility? What do we mean by that? I think, I think at DIME we've been sort of doing the turnkey reproducibility as it's been talked about as computational reproducibility on all the working papers going back 2 years. So nothing that comes out of our shop that's published as working papers in the working paper series is non-reproducible. Now, that doesn't mean people have access to the code and the data. And so there's a lot of discussion even internally as to what we should mean. And maybe just to open, I'd like to hear from the panelists what they think we should mean by reproducibility, at least how they have lived it in their own work and, I guess, life.
Sure, thank you. I'm Owen Osier from the research group here at the World Bank. I have some slides, but before I go to them, I want to just make a few little remarks in response to, and to sort of color in some details of some of what Ted said a few moments ago. So I've now had the privilege, let's call it, of being a referee for the JDE's Registered Reports facility a couple of times, and also I've submitted a pre-analysis plan or a registered report or a proposal or whatever you call it to that facility. And a few things have sort of come to me during that process. First of all, on the pre-analysis plans, that it's a straw man that you can't change any aspect of your analysis or even add to it after submitting or posting a pre-analysis plan. Of course you can. You just got to make clear what was pre-analysis specified and which wasn't. Apparently the straw man, the robot who's unwilling to change from the pre-analysis plan, actually is giving seminars. I gave a seminar yesterday, and the seminar audience said, did you do a pre-analysis plan? I said, yeah, and then I described which was in it and which wasn't. They said, because when we asked questions of the last presenter, whoever that was, I don't know, but it was your straw man was giving a talk there. They said, every time we'd ask, what about this? They say, it wasn't in my pre-analysis plan, and like not answer the question. So don't be the straw man. I know you are the straw man or giving seminars somewhere. Don't do it. Just stop. You can answer these questions even if they're not. Yeah, exactly. You can answer the question. Anyway, so the straw man is out there. He's out there. It's true. It wasn't me also. Another thing that Ted sort of glossed over, and I think, and this is a theme of some of the graphs I'm going to show in a minute, we lump together several different ideas when we talk about pre-analysis and when we talk about replication, and I'm going to be trying to take a couple of those ideas apart, and I think it's useful, for example, to pull apart the idea of registration from the idea of pre-analysis commitment. So registration is really cool because it's extremely low cost, and it helps solve the file drawer problem. So that is to say, I go online, I spend a very short amount of time, I say, I'm going to do a study, it's about political mobilization, it's about holding your government accountable, these are roughly the outcomes, this is the country, this is roughly the data set. Anyway, that's what it's about. Post. That's it. That's the trial registered. And now, if I never publish a paper from that, people know that I tried, and they can reach out to me and try and figure out, is that where the zero is getting buried? Is that where it all stopped? And so registration is so low cost. So I just want to emphasize that, and it helps solve the file drawer problem. Pre-analysis is a step further that can be included in the registration. And then that is really pushing you against p-hacking. Okay, so one of the many functions it serves is this social good, this public good of knowing that the analysis that I finally show you is in fact the one I thought of ex ante, not the one that I tried 87 different specifications and decided to show you my favorite ex post. So that's a pre-analysis plan, and that's a different object. The registered report is yet a different object still, and that was made salient to me. So the JDE, if you saw, there was a blog post recently about the results of the first year, some of which Ted recapitulated. And one insight that comes from that is that it takes about 5 months for the typical case of a registered report to make it from submission through, if it's going to make it to an R&R, to being responded to by the authors, and then reaching that conditional accept stage. That period needs to more or less elapse before the opportunity to look at the inline data occurs. Now, in the World Bank, I encounter projects that are a little bit, working on these projects is a little bit like, do you know if anyone is old enough to remember that film Raiders of the Lost Ark, in which Indiana Jones does various things, and one of the things he has to do early in the film is run from a boulder. And sometimes that's how it feels to work on these World Bank projects. You know, the government is about to implement, and the survey team needs to go, and the instrument was due yesterday, and you're running from this boulder, and then you say, hang on, boulder, wait. The JDE needs 5 months. Just hang out right where you are for 5 months, and then right at the end of that, we'll just keep rolling, okay? But I need to not have the inline. So there are some projects for which it has proved infeasible to submit to the registered reports facility, though it did prove feasible to post a pre-analysis plan. Okay, so it was quite straightforward to bind my hands in terms of the analysis, to say, this is the regression I'm going to run, these are the outcomes, but there was no time for a back and forth with referees. Okay, and further in that back and forth with referees, I would need not only to show them how I have bound my hands to avoid p-hacking, but I would need to convince them that this was even an interesting study. So you can't just submit like, here's my specification, I hope you like it. You know, y equals beta times treatment plus epsilon, I will cluster, thank you very much, the end. You know, that's not enough to argue that this is an interesting paper, which is the question that the JDE referees are going to be trying to answer. So it's a more onerous task and it takes longer. And I do think that it can come across as a bit regressive. And so Ted put up these graphs, and one of them on the right, the theorists aren't doing these pre-analysis plans. And so there's a joke on Twitter. I think Pam Jakila, my wife and co-author, was responsible for one aspect of this joke. It's all a plot by the theorists that we have to do these pre-analysis plans, because you see they've raised the cost of doing empirical work, and they get to keep publishing. But inside the joke is a truth that if we're, you know, I think to do serious empirical work, we're seeing real progress in the scientific method, basically. But we shouldn't lose sight of the fact that we are in a discipline and in but one of the social sciences where empirical work of the kind that we're describing, experimental work, is not the only mode of inquiry. And so we have to ask ourselves, how do we make it still easy for graduate students to enter this field and for professionals to participate in this field when we change the structure of the scientific production process. And getting it on the CV sooner is actually a progressive side to that, where there may be regressive angles. Adding the JDE's registered report facility, I think, is a progressive element to that. And so I really was happy to see that. I think that one nice thing it nudges us to do is not only do we have to argue in such a registered report, I'll never use my slides, but that's fine. You not only have to argue why the results would be interesting if it's significantly different from zero, but you have to argue why it'd be interesting if it's not. And that's a useful nudge privately as well as publicly. Here's what I mean. I had an exchange with Lant Pritchett about this. It's a lot easier to have a null result than it is to have a statistically significant result. How? Don't implement the program, right? Like randomize and then do nothing. Now you got a null. Now that's a joke and it makes no sense, but what if you try to implement the program but fail? How far down that road do you have to go before it becomes an interesting null? What if you try to implement the program and the implementer says they implemented the program, but they kind of blew it? That happens all the time. Okay, so in order to convince me as a referee or you as a referee that this thing, whatever happens, is going to be interesting, I need to be able to be convinced, and the readers ought to be able to be convinced, that this thing, this null or significant effect, is about the object truly of interest. Okay? It's not, so we don't ask ourselves, is it important whether I hoped you would get education? It is important whether you got education. That's the research question. What is the impact of education? Not what is the impact of hoping that you get education. And that nudges us as a profession to measure process outcomes. You can call them lots of different things, intermediate outcomes, first stage. So the idea is we're paying for an intervention. Did the intervention get delivered? Kind of traditional monitoring and evaluation outcomes. Did the beans get counted at all? And then that aspect of the documentation is something that we've left out of a lot of our economics papers, but it's crucial to making nulls interesting. And so I think that not all nulls are interesting. I think some nulls are totally ridiculous and totally uninteresting and not worthy of publication because fundamentally the program was not implemented. And so then it's not a test of the thing that it claims to be a test of. So these facilities encourage us to think through how would we show that the thing that we are claiming to test is indeed the thing that we are testing. So with that, let me show you two really quick slides. Maybe 5 or maybe 20. Let's see. How many seconds do I have?
You have about a minute or two.
Okay. See how many of that minute will be absorbed in opening the file.
Hopefully not too many. It's done this thing again.
59, 58, 57. This is going to be tough.
Oh.
Thank you very much.
It's not a see. That's why we should use PowerPoints for this thing. Do we have the display switch?
So the first picture that I am not showing you is two pictures, one from the best titled paper ever, which is Star Wars: The Empirics Strike Back.
It was there. There it is.
Oh yeah, yeah.
Got it.
Okay. This is from Star Wars. You all recommend, there's Obi-Wan Kenobi, there's C-3PO, and in between is the distribution of test statistics. So the point is, on the left, these are experiments and RCTs, and on the right is other studies, and this is the distribution of test statistics. And under the null, you would see a nice smooth distribution, and with effects, you would see stuff that's way further out to the right. But what's really weird, and what you wouldn't expect to happen naturally under any collection of data generating processes, is a spike exactly at t equals 2. Okay, at the p equals 0.05 level. And we see that spike, particularly in non-experimental data. So the point is there's a body buried here. That's p-hacking, or publication bias, pure publication bias. No malicious intent on anybody's part. But the point is the problem appears more severe outside of experiments. And so as we think about transparency, we really need to think, and there is progress on this front. I don't mean it hasn't been done, but just be aware that the experiments aren't necessarily the place where the publication bias and the p-hacking is the worst. And the same is true in Eva Vivalt's study. There's this spike on that right-hand graph among non-RCTs, whereas that spike at that magical t-statistic of 2 is basically absent when you include all studies, including RCTs. Quickly on terminology, I just want to point you to this paper. This is Michael Clemens' Meaning of Failed Replications. It echoes work by Dan Hammermesh over a number of decades. And the point is, if a thing doesn't replicate, we could mean a lot of different stuff by that phrase. And code verification, the kind of thing that we were talking about at the AEA journals, where they would actually check to make sure it runs, what Florence said about making sure it actually goes, that's one type, and you really want that to work. And then there are all kinds of other things, like splitting the sample to see if the same thing is true in multiple pieces of the sample, or drawing a new sample, or running a new experiment. All of those things are different from one another. Some imply, if they fail, fraud. Some imply, if they fail, typos. Some imply, if they fail, a lack of external validity. Okay, so, and I think we need to, when we confront researchers with their failure to replicate, are we accusing them of fraud? Are we correcting their typo? Or are we just recognizing that what was true here isn't actually true over there? And so I think that's a really important set of distinctions to have as we approach this process as consumers or as producers. You may have seen a study by Galliani, Gertler, and Romero called, well, it doesn't matter what it's called, How to Make Replication the Norm, but the headline was Replication Rarely Possible. This is a graph, and they showed that only 14%, that little blue bit of the donut diagram, only 14% of papers in economics out of 200 that they checked did the code run all the way through. That sounds terrible. What awful news for our profession. Well, it turns out they're not the only ones to actually try and do this exercise. In 1986, there was an attempt. In 2015, there was an attempt. Theirs is the one on the right. And the news is actually good in that we are, as Ted said, in the process of a change in our profession, a change for the better. And so the left one, DeWald, Thursby, and Anderson, the dark blue thing in the middle is, could you get both the data and the programs for the paper? The one on the left is, could you get either the data or the programs? So in general, you could get some fragment of stuff, but could you get both data and programs that are necessary? In 1986, the answer was basically no. For 9% of papers, could you actually get the data and the programs necessary to even try to replicate? Conditional on that stuff in hand, just under 80% did replicate, but that is to say 7 of 9 papers worked out, okay? Out of like 50 or 60 that they looked for. In 2015, the picture got a lot better. The big blue bar in the middle got taller. Gertler, Galliani, and Romero, they see something similar, and they see that conditional on having the code in hand, Florence's check works. You hand it, and then more than 90% of cases it works out. How did they get their terrible 14% figure? They required not just that like you have the code that produces the regressions and the coefficients, but you have to be able to start from raw data. Okay, so this is a brand new standard, a standard that none of the previous analyses had imposed. I want to see your raw survey data and the construction files that take that to the analysis files and the analysis files that use that. So we can raise the bar, but that shouldn't be interpreted as bad news when we raise the bar. When we raise the bar, it should be interpreted as the new goal to strive for. the last thing I want to leave you with is some inspiration. Sometimes replication can come across as an antagonistic exercise, okay? One in which the objective function, it's not very exciting if I test Ben's paper and I find out that what Ben said was true. Headline, it's still true. That's not very exciting. But if I can come to Ben's paper and say, you thought Ben's paper was true, but it turns out it's false. Now you're paying attention. Why? What did he do wrong? Was it fraud? Was it a typo? Or is it just not an external validity thing? When instead you come at a family of papers, and this is more and more possible with things like the replicability, the availability of replication data through like the AEJs and things like this, you can then look for patterns, and whether one paper, Ben's, let's say, replicates in any sense ceases to be the interesting question. The interesting question is, what kinds of paper replicate? Could we have seen it coming? Which ones are stronger, which ones are not? And so this is work by Colin Kammerer and a very long list of co-authors. And so here it was combined with prediction markets. So the blue dots are the ones that replicated. The axes are two different ways of measuring what experts thought about whether they would replicate. And the idea in this graph is that experts had some idea, but they didn't perfectly nail it. This is from their 2016 paper. What is associated with replication? All the things that you might expect. The larger sample size, the more precise the estimation in the original paper, the more likely it was to turn out to work in a separate replication. And here what I mean is they did a brand new experiment that was really well powered to identify the same parameter in another group of usually college students. And then they did a similar exercise in 2018 for a broader class of papers. And here actually the prediction markets worked even better than they had in the original. So what's neat is it's a headline, what fraction of things replicate, rather than whether one paper replicates. A high fraction is news. A low fraction is news. What predicts it is news. And so we can set our incentives well as replicators when we design a study of replication in such a way as not to either attack or support a particular paper, but to analyze a family of papers and thereby contribute to our understanding of our profession as a whole. Thank you very much.
All right, so let's maybe open to others on the panel. How about we hear from Lorena and just go ahead.
Thank you. My name is Lorena Barba. I'm a faculty at GW right here, so I hopped on an Uber to come, and I haven't been here in the morning. And I don't know if you've heard about the study that was released in May of this year by the National Academy of Science and Engineering and Medicine. This was 18 months of work, and I was a member of the committee. And the study was congressionally mandated. NSF commissioned it to the national academies to assess issues with reproducibility and replicability, and in particular to also canvass the various different disciplines to propose definitions that would be most applicable across fields. And that surprisingly is surprisingly hard, because you must have discussed it already, how many different disciplines use these words to mean different things. The final consensus in the for the committee, and what appears in this report, which is available for download in the National Academies Press website. And I want to read the definition for you, just in case you've used the words differently here. The report defines reproducibility as obtaining consistent results using the same input data, computational steps, methods, and code and conditions of analysis. And this definition is then synonymous with computational reproducibility. Same data, same code, same methods give me the same results. Sounds straightforward, but in fact, it's quite hard. For completion, let me say what the meaning of replicability is for this in this report. Obtaining consistent results across studies that are aimed at answering the same or similar question, but each of which obtains their own data. So in this case, the line is drawn at collecting new data. The moment you're collecting new data, the committee defined that as replication. Now, my area, I'm a computational scientist, a computational engineer, and I've been working, I have a computational research group. All of my graduate students write software, research software, and we have been focused then in the area of computational reproducibility. So I want to tell you a little bit more about that, in particular how it appears in the report and how we discussed, the things that are brought up here. That I recommend, of course, that you have a look at. And one of the issues was, well, it sounds straightforward that if you use the same data and the same code, you should get the same answer, right? But there are many there are many reasons why this doesn't work. First of all, something obvious is, well, you could call it inadequate record keeping, but it turns out that record keeping when you're doing computational work is very hard. It can get, you could say, it's not just about having a lab notebook and keeping track of what you did, right? So inadequate record keeping turns out to be something very difficult because it now includes many details of the computational environment, the software dependencies. Many times, perhaps in this group, you're used to doing data analysis and the computational workflow might not be terribly complex. But in some other areas, think about drug discovery or astrophysics, or in my field, computational fluid dynamics, trying to model the airflow around animal batting its wings. It actually comprises a stack of many different tools that work together. And these software tools, keeping track of every version that you used turns out to be quite difficult. Then after, even if you have kept very good records, the transparency of reporting turns out to be a very difficult topic as well for reproducibility, because we have, come to rely on the scientific paper as the main way that we communicate as researchers and the main way that we value the output of research. But being able to reproduce the results that appear in a paper require many other digital objects that are not shared by standard. We don't have the habit. And then again, there's obsolescence of digital artifacts. Even if you shared your data set, is this data set in a format that is going to be readable in 5 years? Is this software going to be able to run in 5 years or 10 years? Is it using certain technologies that naturally become obsolete over time? And this is something we have to deal with and plan ahead for, because technologies will become obsolete over time. Of course, researchers trying to reproduce some work will have some technical requirements, and it makes it that raises the standards for training for the people attempting to reproduce the results. And finally, there are barriers in the culture of research, of course, that make it very hard. Now, I want to mention the aspect again of meticulous and complete record keeping. When you're using computation, this cannot be done manually, and it requires the concept of automation to be brought into the equation. Developing the right tools so that every version of a piece of software is recorded. Well, we have some tools, it's called version control, but the widespread use of these tools is not currently the practice. And then when we talk about both capturing the complete computational workflow and also reporting in a transparent way, neither of these things can be done a posteriori. You cannot, at the moment of, okay, I'm ready to submit a paper, say, okay, now let's find the data to put it on a repository. Now let's collect the software that I use for my research and let's put that on GitHub. It cannot be done at that point. So it has to be built into the research process from the very beginning, and it has to be built into the way that we educate the researchers. And that is also not the practice, even in engineering, even in mathematics, even in chemistry, and highly STEM oriented topics, or even in computer science. Sometimes the practices for that conducive to reproducibility are not in place in how we educate researchers. And in terms of the artifacts, the digital artifacts being operational over time, we need to decide as communities, well, how much time do we want the data to be readable in 10 years or in 20 years? Do we agree that software actually needs to be runnable and needs to compile in 5 years or in 10 years? It makes a huge difference in terms of software, for example. 5 years do make a huge difference. And data, software, and then computational environments is another layer we don't talk about, and that might have another due date that we need to talk about. So that means that we have to develop standards. And developing standards around all of this is kind of a social process that requires effort and dedication and investments. And even if our behaviors and our aspirations are changing, like Ted reported in many fields, the infrastructure, including the social infrastructure for developing standards and then rewarding people for adhering to those standards is not necessarily in place yet. So some work to be done. And this report doesn't solve any of those problems, but it just is a good collection of what's out, what's the current status. So I do recommend it. I'd be happy to answer any questions afterwards about how we do it in my group. We have been working for several years to really develop our computational workflows in a way that are fully reproducible. And I think we're getting there. But if you look at many of the journals that we publish in, and try to see, what the standards are already. Something like Journal of Computational Physics. There's a study recently about the standard of reproducibility of papers published there. The majority don't publish code. The results, not all the parameters are available. Even sometimes when the authors declare their code to be available, you have to contact them, and then they don't answer email, of course. So and even when you have the artifacts available, the rate of reproducibility is usually 50% or below. So we do have quite a bit of work to do in that area. Thank you.
Sure. I have some slides. Could you load them? I can get started while you pull them up. Okay. So I'm bringing the data archivist perspective. And so what that means is I'm actually getting these research NEOMs, these packages, and I actually have to run them, and I have to make sense of them. So you're going to get my answer. Which, reproducibility, it sounds very easy. You're just verifying results. If you give me your data and your code, then I should be able to just press a button and it works, but it never works that way. And I think, Lorena, I'm glad I'm following you because you brought up a lot of the issues. And I think you sort of seeded some of my discussion well. Oh, okay. Oh, great. I can just sit here. Okay. No problem. Okay, so the Odom Institute, for the past 4 years, we have been performing reproducibility confirmation for 2 journals in the political science community. And so what I'm going to talk about is sort of, what our perspective is on reproducibility and sort of some of the concepts that are sort of informing our practices. And then sort of when I say reproducibility, what it means actually in some of our workflows that we have in-house. And I'll go through this pretty quickly. Okay, maybe if I can work the slides. Oh. I promise I can use technology. So we're just going to skip this. Odom Institute is the Social Science Research Center at the University of North Carolina, and they have a data archive. So in the political science community, for the past 20 years, they've been debating reproducibility and the feasibility of actually implementing a standard. There's a seminal work by Gary King in 1995, actually making the case for a replication standard. And he says replication, but it's really sort of reproducibility like we've been talking about today, confirming the results using the same data and code. And so from this, there's been direct policies for these 2 journals to actually, in order to be published, you actually have to have your data and your code executed by us, and we verify that you can get the results. And so these are just, it's a pre-publication, so it's, you need to pass verification to actually get published. And we are verifying the results in the manuscript. And so it's in text, it's tables, and it's figures. So when I talk about reproducibility, that's what we're reproducing. And the two journals, the policies are pretty similar. So there's lots of terms in this space, but sort of what we're doing is really the computational reproducibility. It's the quantitative analysis. You give me your code, you give me your data, but it's not that easy actually to verify the results. And so Lorena has already talked about the definition for computational reproducibility. But what I like about the NAS report is they also talk about the relationship with transparency. So in our experience at ODM, there's a lot more you need to know about the research and about the analysis to actually be able to get the code running and then to confirm the results. And so I would say this standalone data and code is not enough for actually reproducibility confirmation. We need more documentation. Often, I need to understand how you set up your data file, how you set up the variables, if they're coded, or if there's a certain way that I need to load it, or sometimes we'll get multiple scripts. And so in what order do I need to run this? It's amazing the packages I get and I'm trying to make sense of. And I just need more details, especially about maybe software, the versions, the packages, because at least with Stata, I think it was between 14 and 15, there was a big jump. And so if you don't know which version you're using, then it can really change the results that you see. And so thinking about the documentation and the curation, that's what I would add to the reproducibility definition. And so the curation side is not quite the sexy side, it's not actually running the analysis. It's making sure that everything's complete, making sure that, there's enough documentation that we can understand what this code is trying to do, and which pieces of it are actually producing the different results. And also thinking about the file formats that Lorena brought up. Can somebody open and use this in potentially 10 years, 5 years? How long can this replication package actually be rerun potentially and used? So at ODM, we think about it, the curation side, but then we also think about the verification and actually looking at the code and actually trying to compile and run it. And then we compare the results as well. So I think I might just sort of stop there because that was sort of the thing I wanted to say, that we need to be thinking about curation and documentation and provenance to help researchers actually produce higher quality research compendiums or verification packages, whatever you want to call them.
And yeah, so we have 15 minutes to discuss what has been brought up. I think the really nice aspect of this discussion that I had never thought about really, except, for sort of undergrad when I was doing math, was exactly that, kind of the software issue, and put that as part of your package, and that becomes a time capsule that you think you can run, and you have to specify what operating system you can run it on, and all this stuff, kind of a very kind of self-standing time capsule is kind of really interesting. I don't think any of us, at least in our group, has really thought about this. So that's a super cool aspect. Owen had some thoughts you wanted to?
Sure. Thanks. In relation to a couple of things that both of you have just said, no, it's okay, thank you. One is that Professor Barba raised an interesting point about harmonizing terminology across disciplines. The graph that I showed, the three sort of bar graphs about how reproducible things really are, that's from a working paper that was just accepted, and you can find it on my website, about replication. And in the process of writing that paper, I came across this fact that in biostatistics, they actually propose using the terms reproducibility and replicability in precisely the opposite way as they do in Michael Clemens' paper and some of the work by Dan Hammermatch. So they're both English words. I don't mean to pick on any particular discipline. These are English words that have extremely similar underlying English meanings. And so then what sort of scientific special use of the term we tack onto that, so computational reproducibility or something like that, is something that we're adding on. So I think miscommunication is kind of to be expected, but shouldn't be underestimated. So if you want to read the hilarity that I found, look at the footnotes in my paper, and that's where all the funny stuff is. To Cheryl, your point about like software versions. Yeah, so it's Stata, the random number generator changed substantially between Stata 11.1 and Stata 11.2. And I thought at some point when I was writing an economics paper, I should report, just so that in case somebody discovers a bug in some particular version of some software, they could just go like look in any given paper and know like whether this paper is affected by that bug, right? So in my paper, I wrote in a footnote somewhere like this analysis was done in Stata version such and such. The editor asked me to remove that line and said, you can put that in your replication files if you want, but there's no place for it in this manuscript. Why? Because not everybody reading this journal even uses this software at all. Not everybody's even doing applied work. And this is what I mean about thinking about ourselves as part of a discipline that doesn't do anything remotely like what we are doing in this room, okay? We have to be able to speak to them too, and to establish a set of standards that we like is wonderful, but it must also inhabit the ecosystem that feeds us and that we contribute to. So that I just want to don't lose sight of the fact that what we're doing is only a part of the world out there. And I think that speaks to some of the sort of under-rewardedness that we see in things like releasing our survey instruments or, say, producing suppose you're going to go measure some outcome. Doesn't matter what it is in the world. You might want to validate that measure. That is to say, show evidence that it really measures the thing you care about. In a lot of economics and perhaps other social sciences, we think, well, I'm sure it's close. And if you've got it wrong, that's just going to be measurement error. That's just measurement error in your outcome variable. So life is tough. Your standard error is a little larger. It's fine. And from the sort of reduced form perspective of whether your treatment effect is in the right sign and statistically significant, I think that might be the end of the interpretation. But if you want to compare two treatment effects on related measures, you really need to know what those are measures of. But theorists don't, okay? So theorists don't care if you have validated your measure. That's not a contribution to economics, all right, from their perspective. So I think we need to think about how the incentives are set up, and maybe what this provokes is the idea that interdisciplinary collaboration is where the sort of professional rewards to doing the careful work that we would all like to do, that's where those rewards actually lie. And what I think is really nice about the registered reports facility is that I once spoke to a theoretical econometrician, and I described some of what I was doing. Econometrician sits down the hall from Ted Miguel. And this theoretical econometrician said, really, I would never trust my dissertation to data, right? And the wonderful thing about the JDE's registered reports facility is that you don't have to, that you are trusting your research idea and the status it is accorded and the references it might get and the publication quality it might receive. You are trusting that that's all about the design of your study and not the coefficient estimate at the end of the day. So I think that's a really nice aspect of the registered reports facility, that it takes us in some ways back to what should be the land of the social sciences, which is, are we asking the right questions and asking them in the right way, not did the answer turn out neoclassical enough? So I think that's really nice. But I think we should just be aware of that in each of the solutions we propose. Are we adding a burden to ourselves that no one will ever care about except for ourselves? And the thing is, there are people who will care about it. So we have to figure out who those people are and speak to them and make sure that our incentives are set up the right way. Find ways to line your incentives up the right way so that your profession pulls you to do the thing that we all want to do, rather than just doing it out of the goodness of your heart and then not getting tenure.
Okay.
On that happy note.
So how about journal checklists?
Yeah. No, but journal checklists only work for applied journals,
No, I know. So maybe opening it up to people who are sitting around the room, if you want to ask questions to this bright set of people.
Hi, this is Katie from BITS. I have a question for Lorena and Cheryl. Did NASM or ODM, did you come up with criteria for how close is close enough for reproducibility? And if you did, how did that process work? How did you come to a standard?
Well, the report does address that question, but it cannot give an answer to that. The meaning of consistent results varies from field to field and from study to study. If you're doing, we have some examples in the report, like a field study where you're measuring, the population of butterflies compared to certain plants to determine whether their migration patterns are, due to feeding. At the end of the day, what you're going to have is a lot of data that produces some sort of model, and the parameters in that model that are going to be the values that you want another person to be able to reproduce, right? If you're using simulation in a parallel computer to simulate, for example, a climate situation, then it is understood that even if you run the same exact simulation code in a supercomputer, the situation will be affected by floating point error, by the availability of particular pieces of the supercomputing machine that has a million CPUs, working together in the same way, or even a cosmic ray that flipped a bit somewhere. And so the answer is actually going to have to be understood as an ensemble, and then the statistics of that ensemble so that the researchers have to come together and agree upon what it is to have come to consistent results. And it's going to be, as those two examples that I give you, very different from field to field. Sometimes if it is just about running a statistical analysis of precisely the same values, you do expect what we call bit-by-bit reproducibility, which is you having the exact same number up to all of the decimal points. But many times that's not the case, and you have to agree on what it is, the level of uncertainty that is just inherent in that problem, or even a number that you're computing. Every answer, every result has some uncertainty attached to it. Understanding that uncertainty is part of the work that we need to do, because otherwise we don't know the meaning of reproducibility for that situation. Yeah.
So at ODM, we do have categories in terms of once we do the reproducibility checks, we give a report back to the editors, and the categories that we assign are success. That means that we are able to verify the actual results. And then the next category is minor issues, which usually that is, we're able to mostly get the results, but maybe your code file, we had to change, you had absolute paths and we need relative paths. Or there's some missing documentation, but we were able to make enough sense of it that we were able to run it and verify it. Major usually means that we got major issues, that we got different results potentially. Or sometimes we were able to run part of your code, but then it broke and we couldn't finish. And then the final category is not attempted. And that's usually you're missing a lot of files, or your code is so broken that we can't even get it going. We can't figure out exactly what's wrong. It would take too much time. So.
Let me actually respond to that from an economics perspective at the AEA. So I'm Lars, data editor at the AEA. When we define, is it good enough in terms of precision, it's bitwise. Otherwise, you have to explain what is the expected variability in the instructions. That sort of goes along the same lines. If there is an expected variability that you cannot control for with all the means that your programming code might have, random seeds, defining architecture or whatever, then you should explain that and say what is the expected range of the variation that you see. Otherwise, it goes back. The editors have chosen that if it doesn't correspond to bitwise, you will need to adjust your tables. So that's a fail.
Set your seeds.
Just to note that we do parallel computing, and in parallel computing, bitwise reproducibility is simply not feasible. And so what one needs to do is accompany every result with the uncertainty attached to it.
Well, first of all, I want to thank all the panelists for giving all of us really good ideas for how to preach to the non-believers, because that's always a challenge. And I wonder if any of you have and that includes Ted, by the way, very inspiring talk. And I wonder if you have any advice for me. Like, so I'm on the editorial board of an interdisciplinary education research journal, and I'm just thinking about, like, how do I even approach my colleagues with this idea of, trying to build in some kind of guidelines, let alone rigorous guidelines for sharing data and code, especially in a world where a lot of the work that researchers are territorial about is the amount of effort that they put in to try to gain access to data, and then they're being asked to sort of fling the doors open and share it with anybody.
I'm really curious to hear others' perspectives on this, because I feel sort of both sides of this. But one slide that I flipped by is a thing that relates to some things that Ted pointed out. Whether journals require data is a great predictor of whether this study will ever be able to be reproduced. In the computational sense, at the very least. So in the sense that, we all in principle could say that the data are available, but 10 years later, when somebody sends you that email, the likelihood isn't that great. That laptop died, the notebook is gone, it didn't make it to GitHub, whatever it is. So I think that an argument that I would make if I were on the editorial board that you speak of is our results are going to be in the credible bucket if we do this. And I think that there's several studies suggesting that pattern would hold. That doesn't answer the question, what do I do about my hard-gotten data? And I think there are some ways of dealing with that. I'm curious what other people have to say.
If I may add to your answer, and you can say about this something about this as well. The journal that you guys are working for, the journal Political Science, that requires all accepted papers that go through this process, right, of having their computational reproducibility actually verified by an external group. That only increased the prestige of that journal, so it turns out that you can get known for a higher level of quality check and demands in your community. And it doesn't have to be all or nothing. One can start by incremental steps, certainly. But I think that rewarding the good behaviors combined with the stick for bad behaviors always works well. So you have to, make a good mix of those two things. In the case of the Journal of Political Science, once your paper is accepted, it will not be published unless it passes these checks. So that's really a high bar. But certainly you can reward authors that commit to higher levels of transparency in some ways.
Can I just say one word? Embargo. That's a way to take the edge off.
So,
just
sorry.
one question. So how should we deal with papers that are based on confidential data, the data that are legally confidential, or data that can't be released for, say, 72 years, just to pick a number? Should we not allow them to publish in the prestigious journals? Should we say there'll be special journals for those data sets? Like, what should we do?
I can answer this. And this relates a little bit to your question, too. So we do get data sets that are proprietary, that they cannot...
No, you can't have the data set because it's legally protected.
And we do get that. I'm going to answer your question.
Okay.
We do get cases of this. So, and... Okay, so ones that we cannot have access to the data, what we normally do is we review the documentation and we inspect the code to the best that we can, and then they'll get a badge that says open materials. We do have some that we will sign non-disclosure agreements and to be able to gain access to the data. And so in those cases, the data is not published with the rest of the verification package, but we are given access to it, and then we can review it for just to make sure that, the data and the code together produce the results. So we've had those cases happen, both type. And just to respond to the previous gentleman's question about making the argument, I would add that less than 10% of manuscripts that we've reviewed actually pass the reproducibility check on the first round. And we've reviewed over 275. So you might want to tell your colleagues that we're catching lots of errors and improving the quality of the research that gets published. And also our verifiers, which are statisticians and doctoral students, actually have reported to us that they feel like doing this verification work is actually improving their own research and the integrity of their research.
Sorry, I also wanted again to give the economics perspective a bit of a twist on what you guys are doing at ODEM. We have actually started to ask people about how one could access data, and that is something that we are very emphatic about. So when you say the data is not accessible, we will test that hypothesis. And there are cases where, okay, we'll believe you, and we have gotten agreement from third parties to actually run the verification for us who have access in a timely fashion that we could not gather. So there are a variety of responses to that are developing. This is very much in the developing sphere. The French have just launched an agency that is embedded within their restricted access environment that will do the checking for free for now because they're somehow funded, and will issue a certificate. The French confidential data, so if you were to work with the French data. That is an interesting approach. Is that scalable? I don't know. Is it sustainable? Can we do peer-to-peer verification? So Odin didn't run it, but somebody else did, and how do we assess that that person's credible, et cetera, are things that appear. So we will get access as well to the extent that we can, but when we can't, we will investigate other options. Can we send somebody out there, et cetera? And the question about incentives to actually, I've gone through all this work and I've made my data available, et cetera, is a tricky one in the sciences because we don't typically, especially not for tenure cases at present, get credit for having prepared very complex data, and this is your data product that we're now citing. There is currently not a very strong argument that holds empirically that this will really benefit you. So that is a faith issue to do so. There are, however, variations on open access license. You're not throwing the data out there necessarily. You may want to have a license that says you can get access to my compilation of this data if you cite my paper, and that is the restriction on the data. That doesn't qualify as open access, so some people might not like that, but it is a way to garner more availability that doesn't contradict reproducibility. It only goes against sort of the open access credo. And that's a very difficult question to assess because we're typically not trained or even aware of the licenses or conditions of use on a lot of the data that we have. And that is a discussion that is ongoing, I would say.
I add a reaction to what you just said. The National Academy's report has amongst its recommendations one thing that I think, one thing I really believe could be an agent of change, and that is that funding agencies introduce reproducibility in the merit review process, so as a merit review criteria among them. So just as you have, for NSF reports, broader impacts, and you have to have some sort of statement about how your research is going to impact society, you would have to make a case for the reproducibility of the study that you're going to carry out, and that would be assessed as part of the review of that proposal. So that changes things a little bit because then to be more competitive in getting funding, you'd have to work more reproducibly.
So I think we all have a million more questions, particularly for Lars. But anyway, we'll keep them for coffee break, I guess, and maybe move on to the next panel. I don't know what the agenda is anymore.